Hi, welcome to this on Maths paper for the Edexcel Foundation Tier Paper 3 Maths GCSE. Enjoy! Hi, I'm Chris Gilpin and welcome to this prediction for the Paper 3 Maths paper. I hope Paper 1 and 2 have gone well for you. And I'm not going to talk too much, but don't forget that these papers are on our website on maths.com, which I'm sure the link will come up there now. If you click on the link, it will take you to the prediction on our website. Don't forget that the prediction on our website changes the numbers in the questions, so you can do it as many times as you want, and you're not just getting the same answers each time. This video will go through all of the answers to a set of numbers. So if you don't understand a question, come to this video and you can see how to do it for maybe a different set of numbers, but you can get the methods. If you check out our website, we've got tutorials for everything. We've got topic busters, demon questions, practice papers, all sorts of things. So please check out our website on maths.com. If you enjoy this video, please click like. If you want to see any other stuff from us, especially over the next few days, please click subscribe. Thank you and enjoy the video. So we're asked to shade in 3/6 of this shape. So if I cut this shape into 6 going downwards, we're asked to shade in 3 of them. So 1, 2, 3. Now some of you might realise that 3/6 is the same as a half, so we're shading half of it, and looking at that we've shaded in half of it. Some of you might look at this and change that so that it's 6/12, and there's 12 squares in total, and so we're shading 6 of them. However you do it, it's up to you, but as long as you shade in 6 of the 12 squares. You will need to be familiar with the names of three-dimensional shapes. So the one we have here is a triangular based prism. So a prism is a shape that you can cut anywhere along one of the axes, so anywhere along here, and it would look exactly the same. It would look like a triangle. The first bit of this, triangular based, is just the name of the shape at the end, the name of the shape at the end of the prism. So you can have a hexagonal based prism or anything like that. It says write down the number of faces. So the faces we can see, well, the face we can see here is a triangle, so that's 1. Then we've got 1 along here, which is a rectangle. So we've got 2 that we can see, but there is also going to be a third one round here, which is also going to be a rectangle, a fourth one at the bottom, which is going to be a rectangle, and then a fifth one round the back, which is going to be a triangle, just like number 1. So in total there are 5 faces. Try and remember what a face is. A face is something you can lay your hand down flat on. An edge is something that you can run your finger along, so that's an edge there. And vertices, or vertex, is something that if you put your finger on, it would be pointy. So there are going to be 6 vertices. On this scale on the side of the jug, we're not given the little tiny notches. So the word estimate means that we're not going to get it exactly right maybe, but we're roughly going to be correct. Now there are wrong answers to this. So if I wrote the answer 22, which would be down here somewhere, that's clearly wrong because we know that the water is above 30. We know the water's between 30 and 40. And if you have a look, it's less than halfway. So we're expecting a number that's below 35. I think if you wrote the number 35, you would get that wrong because it's clearly less than halfway. I think the numbers, probably to get it right, you might get away with 34, but definitely 33 or 32. I think, personally, it's closer to 33, but some of you might look at that and think it's closer to 32, and chances are we'll both get the marks. So So we're asked for an even cube number. So the cube numbers are 1 cubed is 1 times 1 times 1, which is 1. The problem is that that is an odd number, so let's try 2 cubed. Now 2 cubed is 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So 8 is an even cube number. Now you could have also had 64, which is 4 cubed. 6 cubed is above 100, so that would not count. So 8 or 64 are the correct answers. With stem and leaves, the tens, and sometimes the units, but mainly the tens, are in this column, and then the units go in this bit here. So first of all, I'm going to pick the smallest number, and it's easier to do this by doing it smallest to biggest, because the units here must be in order of size. Now the order goes, the smallest go on the left hand side and the biggest on the right hand side. However, if you're doing a stem leaf over here, the biggest go on the right hand side, sorry, the smallest go on the right hand side and the biggest go on the left hand side. Basically the smallest must be as close to the middle and the biggest must be away from the middle. Okay, so the smallest one we've got is 30, so we're going to do 30 first. Now we've got the 3 already, so we're just going to put a 0 there, and that represents 30. Then the next smallest I think is 33, so the 3 goes there. I think the next smallest is 39, so the 9 goes there. Okay, and that's the 30s done, so let's move on to 40s. 41 goes there, 43 goes there, 44, 48. And the last few, so 52 and 52, well they're the same, so they can be next to each other, and 64. So the smallest go on the left, and then you get bigger as you go to the right, and that's really important because you need to do that to get the right marks, or to get the right correct answer. Okay, the last thing to do is the key. Now the key is just pick a value, any value. I always pick the one at the top left, but it can be any value. It doesn't even have to be a value on there. And you do 3 line 0, which I've just copied the bit I've done in the yellow, means 30. Now you might ask, why do we need that? Because it's always going to be 30. Well, not quite, because you can get ones that are 4 line 1 means 4.1, which is why these ones here aren't always going to be tens. Sometimes those will be units and you'll be writing down the decimals, so just look out for that. Now you need to have, first of all the numbers in the stem and leaf, secondly them in order, and thirdly the key. That's what the mark scheme is going to say. Okay, so when simplifying it's really important to understand what like terms are. This is an x term and this is also an x term. This is a y term and this is a y term. So we're going to add the x terms first, so 13x plus 7x is 20x. And then we're going to add the y terms, so 3y plus 2y is 5y. Now it can be tempting to try and add these together, but these are unlike terms, they're not like terms, so we can't add them together. You can multiply them, so if we times them together it would be 100xy, but when we add them we can't add them. That is our answer. Okay, so we're asked to round to 3 significant figures. So what I'd try and do first is write the number down. Now, with significant figures, we start counting at the start of the number. We don't start counting the decimal point. So I'm going to start counting here. And I'm going to count 1, 2, 3, and I'm going to draw a line down. Now, all the numbers to the right of that line are going to reset to 0. But before they do, we need to look at this number, and this is called our decider number. If that number that I've circled in blue is 5 or more, it means the 7 goes up to 8. If it's less than 5, the 7 stays the same. Now because it is 5, that 7 will go to an 8. Now be careful here, the numbers to the right don't disappear, and some students, when they've done decimal places, they think they just go away. With significant figures, you have to remember that they turn to 0. Now they do the same with decimal places, it's just because they're after the decimal point, we don't need them anymore. But these 3 zeros here are what we call placeholders. So, for instance, if you're asked to estimate the size of a crowd, and there was 207,518 people, you wouldn't say that that was roughly 208 people. You would say that's roughly 208,000 people. Alright, so we're asked to find 8.9% of 457. So first of all, I'm just going to convert 8.9% into a decimal. So this is it as a percentage, and as a decimal, I'm just going to divide it by 100, and you always do that to percentages to find decimals. So 8.9 divided by 100, and that gives me 0.089. And all I need to do is get my quantity and times it by that decimal. So I'm going to times that by 457 equals, and it says 40.673, and it wants it to 2 decimal places, so that's going to be 40.67. It's important that we're comfortable with converting between ratios and fractions. So having a look at this question, there's red on the first one is 8, and blue is 17. So for every 8 red, there are 17 blue. And it's asked us for the fraction that are blue. So there are 17 blue, so 17 goes at the top of the fraction, but how many are there all together? And so it's tempting to put 17 over 8, but it's all together. The bottom of a fraction is the total, so we need to do 8 plus 17, which is 25. So the fraction is going to be 17 over 25. Okay, the next one asks us to work the other way. So we've got green to black counters, and there's that fraction that are black. So there's a couple of ways of doing this. I could write down them as fractions actually, so why don't I try that? So we know that there are 4/7 that are black, and we know that there are only green and black, so there must be 3/7 that are green, because it has to add up to 7 over 7, which is 1. So looking at that, what we can do to both sides, and I can put little lines down here, I can times both sides by 7 to simplify the fraction, to simplify the ratio even. So when I times the left by 7, I get 3, and when I times the right by 7, I get 4. So the ratio of green to black, and be careful that you have it in the same order, so we need to have green then black, is 3 to 4. And make sure that it's in simplest form, which it is. Make sure that you know the names of the parts of the circles. So a diameter is a line that just goes across a circle going through the centre. If it doesn't go through the centre but it goes across the circle, it's a chord. A bit of a circumference is the whole way around the circle. A bit of a circumference is called an arc. And there's a few more parts of a circle you need to know. Now, on this question, there's a line which touches the circle just at one point, and it's a straight line. The name for that is tangent. Okay, so we're asked to find the length marked x. So it's a trapezium, so it has one pair of parallel sides. And to work out what the area is, we add together both the bases, which are the two parallel sides. We halve it, and then we times that by the height. Now the height is the thing that connects both the bases at right angles. So I'm going to write all that down. So we're going to do half of x plus 1.7. I'm going to times it by the height, which is 2.7. That'll give us the area. Now we're told what the area is. It says the area is 4.05. So this becomes a solving question. So I'm going to put my lines down on the equals. Now on the left hand side, let's have a think what I can do. Well, I can expand that bracket, so it becomes half x plus and I can use my calculator here, I'll probably do it in my head, 0.85, and we're going to times that by 2.7. So we're going to expand it again by timesing both of them by 2.7, so 0.5 times 2.7 is 1.35 x plus 0.85 times 2.7, which is 2.295. We should put the equals in here, because I've not done anything to the right hand side yet. So I'm going to take away the 2.295 from both sides to get the x on its own. So 4.05 take away 2.295, and it gives me 1.755. Let's extend my lines a little bit, and we divide by the 1.35 to get x on its own. So divide by 1.35, and it gives me the answer of 1.3. Now there's different ways of doing that. I could have divided both sides by 2.7 and then times both sides by 2 at the start, and that would have also worked, and then taken away the 1.7. Probably would have been easier, but I thought this might have been easier to show, but it's up to you, as long as you get the answer 1.3. Now I can check that, so I'm going to do 0.5 times brackets 1.3 plus 1.7, close brackets, times 2.7, and it gives me the answer of 4.05, so I know it's correct. Okay, so there are quite a few different ways of doing this question. One way I'm going to show you now, the fact that £1 equals, not very good at drawing euros, 2.23 euros, and we need to get it equal to 2,676. And so we've got to work out how do you get from here to here. Now the way of doing that is 2676 divided by 2.23, and all on the calculator. So we know we've got to times that by 1,200, which is what the calculator told me when I did 2676 divided by 2.23. Now I can check that by typing 2.23 times 1200, and it gives me 2,676. So if that works that side, it has to be able to work this side as well. So I'm going to times this side by 1,200, which is quite obvious. 1 times 1,200 is going to be 1,200, and that's going to be my answer, 1,200. Now there's different ways of doing it, different ways of thinking about it. What you can think about is to get from pounds to euros, we times by 2.23. So therefore, to go the other way, we're going to divide by 2.23. And so you just do 2,676 divided by 2.23. There's loads of different other ways of doing it. You can do it with ratios as well. Okay, so we're asked to find the midpoint, which is just kind of the halfway point, and we're given 2 coordinates at the start and end of the line segment. And a really easy way of doing this is you're just finding out the average of the x coordinates and the average of the y coordinates. So to find an average, we're going to do the x coordinates first. You add together the 2 coordinates, the 2 x coordinates, and divide by 2, because there's 2 numbers. So 2 plus minus 1, well 2 take away 1, because the minus will win against plus and a minus. So 2 take away 1 is 1, and divide by 2 is just going to be 0.5, or just a half. The y's, so here we've got minus 5 plus 2 over 2. Minus 5 plus 2 is minus 3 over 2, which is going to be minus 1.5. So the coordinates are 0.5 minus 1.5. And if you think about it, half is halfway between 2 and minus 1, so that makes sense. And minus 1.5 is halfway between minus 5 and 2. Okay, so we're given a regular polygon, so that's going to be quite an important word there. Regular means that all of the sides, angles, and exterior angles in this polygon are exactly the same. So if I added another one here, this would also be x. If I put another exterior angle here, all the way around this, they're all x. They're all the same, and there's 16 of them in total. Now the one thing we know about exterior angles is they always add up to 360. So to find out what that angle is, we just get 360 and we divide it by 16 because there's 16 identical exterior angles. So I get my calculator out, 360 divided by 16 equals, and it's 22.5. So we can check that. We can do 22.5 times 16 and it has to add up to 360, which it does. At first glance, this seems like a really easy question. It seems like the answer will just be 80. But we've got to understand the way that bearings are written out. It says work out the bearing of A from B. It means that we are at B and we're trying to find where A is in relation to B. So the actual question is asking you for this angle here. Now don't forget, bearings are the angle going clockwise from north. So not so easy. The first step of doing this, and there are different ways of doing this, is just draw a line. In fact, I'm going to use my straight line one. Just draw a line straight down at B. If I can get it right, there we go. Now, north lines are always going to be parallel, and we can use that to work out this angle here. This angle here will be the same as this angle here because they're Z angles or alternate angles. So that's also going to be 80. We know this one is a straight line, so we know this is going to be 180 degrees. So all we need to do to work out the bearing is do 180 plus 80. And when you add them together, you get 260. So the bearing is going to be 260. Now there are other ways of doing it. You could have worked out this angle, because this angle and the 80 degrees over here are co-interior, interior, or allied angles, whichever one you want to call them. So they will add up to 180. So we know that one's going to be 100. And then what we could have done is 360 take away 100, because it's the full circle is going to be 360 and we don't want that 100 one. You'd also get 260. So for this question, we just need to remember the area of a circle. Now the area of a circle is going to be pi r squared. Now that's the area for a full circle, my dodgy circle there, but we only have a quarter of it. Now if you have a look, that length there, the 22 centimeters, is going to be the radius of a full circle if I drew the circle properly. So we know what the radius is, and all we do is we times it by the fraction of the circle we have, which is going to be a quarter. So it's going to be pi times r, which is 22 squared, times a quarter. So I'm going to do that on my calculator. Pi times 22 squared, and then you can press equals and then just divide it by 4. That's the same as timesing it by a quarter. And the answer I get is 380.1327 blah blah blah. And so to two decimal places, that's going to be 380.13. Okay, so we've got a scatter graph question, and the first question asks us just to plot the information from the table into the scatter graph. So we've got ice cream sales at the top and temperature at the bottom, which is not kind of the same way around as on the graph, so we've just got to be careful. So the ice cream sales are 46, which is here on the scale, and the temperature is 31, which is here on the scale. Just check that you're looking at the scale correctly. So we're looking about, let's have a look, about here. Okay, next one, ice cream sales 40, which is here on the scale, and temperature 34, which is here. So we've just got to be careful, and it's about there. So those are the two plots that we want to take. Next question says, on another day had an average temperature of 45 degrees. Use the scatter graph to estimate the sales of the day. Now, you need to get used to just drawing a line of best fit to any scatter graph that you come across. You will have to do it, okay? So just do it. Just, even if it doesn't ask you to, just draw a line of best fit. Now, a line of best fit is just a line that follows all the data like that. You should have roughly the same amount of data top and bottom, but it doesn't matter if it's not perfect, okay? So let's have a look. So we've got average temperature of 45 degrees. So we're going to draw a line up from 45 degrees, which is about there. And we're going to draw, oh, the line didn't come up. So let's draw that line there. It's refusing to come up for some reason. Let's try another one. There we go. Let's try another line. Okay, let's do it the old-fashioned way. Okay, and then we draw a line across from where it's the line of best fit. Now, to me, that looks like about 55. But if you had the same question and you came up with a different answer of 54 or 58, it still can be correct because you might have drawn a slightly different line of best fit. Okay, so don't worry if you sit down next to someone, do the same question and get a slightly different answer. Just draw the lines, straight lines, unlike mine, onto your diagram to show the examiner that you worked it out. So we've got 55 sales we're predicting. Now, what do we notice about this? Well, look at where all the data is. All the data is here, and yet we're estimating outside the range of the data. Okay, it's called extrapolation, where you do that. So the problem with that, if you imagine we do a graph of height against age, so we have age at the bottom and height up the side, then when you're very young, you grow quite quickly. And if someone extrapolated your data and said, oh, okay, well, that growth is going to continue, when you're 80 years old, you're going to be 20 foot high. Well, that doesn't make much sense. It's because we're quite confident with down here because we've got data for that, but we're not very confident with this bit here. We don't know whether the trend continues. Now, with ice cream sales, if it's ridiculously hot, no one's going to leave their house. They're all going to be sitting inside with their air conditioning or sitting in their car with their air conditioning. So we know it probably won't continue. So if you just say that the estimate is outside the range of the data, and if you want to really impress the examiner, then you can use the word extrapolated. It's been extrapolated. So you'll need a calculator for this question. The different calculators do things slightly different, but by far the most common calculator, and if you haven't got one, I would recommend them, are the Casio calculators. Mine has a shiny solar panel on the top, but you don't need that. The average battery life lasts way longer than you'll ever need the calculator. So the first button I would press, and there's different ways of doing this question, is the button to get the fraction, which on the Casios looks like this. And that will make a fraction appear on your calculator. Now, some of the older ones, the fraction looks a bit weird. It involves like a symbol like this. And actually on the new ones it can, but you need to change the settings if it does that. It should open up, it should look something like this, like a box and then another box, and there should be a cursor blinking in this box. Okay, so we want to fill in this top box first, since it's already flashing. So 76.8 plus 81.9. Okay, and so to shift downwards on the Casio calculators, there's a sort of cursor, like a cursor stick, a direction button thing. It's the big blue button beneath the screen on most of the calculators, and you just push the down to go to the denominator of the fraction. And then we need to fill in this bit here, so 0.19. And then to get the squared button, it's on like that. So you just press that, and it looks exactly as it does in the question on the screen, so you know you've got it right. So you press the equals, and my one comes up with 4396.121884. Now, it might be tempting to try and round that, but it says it wants all the figures, so just put them all in. Now, if your calculator is set to a mode which it's going to show even more numbers, then normally six digits after the decimal point is more than enough. They won't require you to go to 100 or 200 decimal places. On this question, that's actually an exact amount. Okay, so write down correct to two significant figures. Now, to do two significant figures, we start counting at the start of the number. So I'm going to do a red line where you need to start counting. And you just count 1, 2 numbers. So the blue line is where I've stopped counting. Now, all of these numbers here are going to be reset to 0. They're going to go away. Well, not quite. Let's come to that later. Now, this number here, the 9, is what we call a decider number. Now, that number is going to go. That 9 is gone. Okay? But before it goes, we need to see whether that is 5 or more or 4 or less. If it's 5 or more, it pushes that 3 up to a 4. So the answer will be 4, 4, and then you'd think, oh, okay, that's it rounded, and you'd write that in the answer column. But when I said they disappear, they don't quite disappear. All the numbers above the green line that I've just drawn reset to 0. They turn to 0. Now, if you think about it, if I don't know what would have a decimal place, but if you have a number 4,396.121884 written down, and someone says, "Can you tell me roughly how much that is?" Then if you say the answer of 44, that's not roughly 44. It's nowhere near 44. So the 9 and the 6 will turn to 0. And actually the other numbers do too. But these numbers here are not changing the number at all. These 2 zeros here will make that 4,400 instead of just 44. The other numbers after decimal point, we might as well get rid of them. So the answer is 4,400. Okay, because we don't need to show these numbers. Now, the reason students make this mistake is they're so used to decimal places. Now, decimal places, you always remove them because they're always after the decimal point. But with significant figures, they need to turn to zeros. These questions are just based on a few rules of indices. The first rule says that if you've got two powers with the same base, which these two do, because they're both a, you add the powers. Now, if you think about it, a squared is a times a to the power of 6 is a times a times a times a times a times a. So in total, we're timesing a by itself 8 times. So it's a to the power of 8. The next rule says if you've got a power inside the bracket and outside the bracket, you times them together. So it's m to the power of 3 times 6, which is m to the power of 18. Now this last one's a little bit more complicated, and I'm going to write it out so I've got a bit of a larger one to play with. Okay, first thing I focus on is the number. Now 55 over 11, so I know that 55 divided by 11 is going to be 5. 55 divided by 11, that's all we've got to do. And the reason we can do that is there's only one term at the top and one term at the bottom. A term is defined by, whether there's a plus or a minus, and there's no pluses or minuses here. Okay, so next one, we've got the r's that we want to divide. So we've got r at the top and an r at the bottom. Now this r at the top is technically r to the power of 1. Now when we do r to the power of 1 divided by r to the power of 8, which I'm going to write out down here so I can show you, you take away the powers. So when you times them, you add the powers. When you divide, you take away the powers. So that's r to the power of minus 7. Okay, now we're left with the s's, and it's the same thing with the s's. This time we're doing s to the power of 15 divided by s to the power of 8. So it's going to be s to the power of 15 take away 8, which is 7. So my answer would be 5 r to the power of minus 7 s to the power of 7. Okay, so we're given the density and we're asked for the mass, and we can work out the volume. So the first thing I'm going to do is just draw my triangle, and it's density, mass at the top, volume at the bottom. So to work out mass, I'm going to do density times the volume. Okay, so we go, first of all, have to work out the volume. And of a cuboid, it's just timesing all the dimensions together, so 33 times 22 times 7. So 33 times 22 times 7 on the calculator, and I get 5,082. And so to work out density, to work out mass even, we're going to do volume, density times volume. So density is 2.1. Let's just check the units, grams per centimeters cubed, so that works. 2.1 times 5,082. So 2.1 times 5,082, and I get 10,672.2. Now check out the unit of mass in the density. It's grams per centimeters cubed. So that's going to be grams. Now be careful, because the answer is wanted in kilograms. So I'm going to divide that by 1,000 to get it in kilograms. And it says to 2 decimal places. So it's going to be 10.67. Okay, so we're asked to find the length of the line AB. And the way of doing this is you work out how far across you go and how far up you go, and by doing that you create a right angle triangle. So we go 2 across here, 2 jumps across, and if you don't know that that was 2, let's just do a different method. So to get this other one, 1, 2, 3 jumps up, or you just know that it goes up to 4, down to 1, 4 take away 1 is 3. So it's a right angle triangle with sides 2 and 3, and we're looking for the third one. Now the one opposite the right angle is going to be labelled as C. These two, it doesn't matter, I'm going to call that A and that B. We use Pythagoras' formula. So A squared plus B squared equals C squared. And A is 2, so 2 squared plus 3 squared, because B is 3, equals C squared. Let's put our lines in. So it's going to be 4 plus 9 equals C squared. 13 equals C squared. Square root both sides, and let's get my calculator. So square root of 13 is 3.6055 blah 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 equals C. So to 2 decimal places, it's 3.61. Now be careful, sometimes it will say that it's done on centimetre square grid, so you might have a units attached. If you want to put units but it doesn't say any, you can just write 3.61 units. Alright, so we're asked to draw a frequency polygon, and the only error you're going to make with this type of question is figuring out what a frequency polygon is. Now, a frequency polygon is where you put little crosses at the points, and the points lie at the group's midpoint. So we've got our first group 0 to 10, so the midpoint would be 5. Next one is 10 to 20, so that's going to be 15. Then 25, then 35, then 45. So the first one's going to be at 5, and it's going to be 6 high. It's going to be like that. Next one's 15, 22. So 22 would be about there. 25, 59, so 59 would be right up here. 25. 35, 15. A little bit lower than that, but that's fine. 45, 4. Now we're only halfway done, and my points aren't exact because the screen I'm using isn't the most precise, but it's good enough. We're only halfway done because what we need to do is join these up with straight lines, so no curves needed. And when you join them up with straight lines, do not ever join up the last 2 points. You're not actually trying to make a polygon, okay? So don't ever, when you join them up, whatever, right? Don't ever draw this line here, okay? That's not a good thing to do, so make sure you don't do that. Okay, and that's it. So midpoints, crosses, and then join them up with straight lines if you're asked for a frequency polygon. Alright, so it says that the town council is saying that over a quarter of the stores get over 30 customers. So we're going to see whether that's right. So over 30 customers would be these two groups here, so 30 to 40 and 40 to 50. So that is 19 altogether. So that's 19 out of, and let's add all the rest up, so 6 plus 22 plus 59 plus 15 plus 4, out of 106. It didn't say it in the question. So it's 19 out of 106, which as a decimal, 19 over 106 be 0.179 to 3 decimal places. So what I would say in the exam is no, because that is 17% or 17.9%. So it's less than 25%. And just write a sentence saying that yes, it's close, but it's not quite at 25%, because even rounding up to the nearest percentage, it's 18%, which is 7% lower than 25%. So just make sure you write all of the numbers in an answer that answers the question. Okay, so for the first thing to do with this question is to write it out twice. Whenever you square something, you times it by itself, and itself is the bracket x minus 15. And there are multiple ways of doing the next bit. I'm going to use the grid method for this one, and we put the first bracket at the top, so x minus 15, and the other bracket down the side, which is just x minus 15 as well, and we're timesing, so x times x is x squared, x times minus 15 is minus 15x, x times minus 15 is minus 15x, and then minus 15 times minus 15 is plus 225. Okay, then these two here will add together. So when we write our answer, it's x squared minus 30x plus 225. Now the really common answer to this is people thinking it's x squared plus 225. Okay, and that is wrong. Okay, students do that, and I'll put a big cross through it. Students do that because they don't understand that you're squaring the whole bracket, you're not just squaring the things inside the bracket. Okay, so I'm asked to complete the Venn diagram, and the E at the top I like to think stands for everything. So all of those numbers need to fit somewhere in this Venn diagram. And we're going to put the square numbers on the left and the odd numbers on the right. Now there's different methods of doing this. What I like to do with this type of question is just do it one at a time. So we're going to start off with the 16. Now 16 is a square number, but it's not odd. So I'm going to leave that here. 75. Now 75 is not a square number, but it is odd. So I'm going to put that there. Now 1 is a square number and it's odd, so that's going to go in the middle. 4 is a square number but it's not odd. 28. Now 28 is not a square number and it's not odd, so that's going to go out here. 9 is a square number and it's odd, so that's going to go there. 93 is not a square number but it is odd. And 2 is not a square number or odd. So that's going to go on the outside here. And I like to just add them up, find out how many numbers we've got in our Venn diagram. So 1, 2, 3, 4, 5, 6, 7, 8. And find out how many numbers we should have. 1, 2, 3, 4, 5, 6, 7, 8. So we haven't missed any, because it's quite easy with this type of question to miss a number out. Okay, so we're asked to write 88 as a product of its prime factors. So the first thing to do is write 88. And then we have two shoots coming from it. Now I need to find out which two numbers times together to make 88. Now a little tip, if you've got an even number, always pick 2. So 2 times 44. Now whenever we get to a prime number, we always circle it, because that's finished. So 44, we can get another 2 out of that, we'll divide another 2 out of that, so 2 and 22, 2 and 11. Now 11 is also a prime number, and when you're left with just prime numbers, then you write your answer out like this. Now if you're also asked to write it in index form, that means instead of 2 times 2 times 2, you're going to write 2 to the power of 3 times 11. Now don't work that out, because that will give you 88, so 2 cubed times 11 is 88. Okay, so we have a set of simultaneous equations, and I'm just going to start off by just writing them out to give myself a bit more room, because it's a little bit too small otherwise. So I'm just copying out the question. Now, there's a list of things we need to do for these, and there are different methods. I'm just going to go through the main one. The first thing is I need to get either the x's or the y's the same coefficient, so the number before them needs to be the same, ignoring signs. Now looking at this, and I'm going to label these A and B. Looking at this, if I double A, then the x's would become the same, because they both have a coefficient of 4. So what I'm going to do now is I'm just going to write 2A. So I'm going to double everything in A. So double the 2x to make 4x, to make the x's the same. Double the 5 before the y, so that's 10y now. And double the 24 to make 48. Now next I need to probably, and it's normally the case, if I write down B again, it just makes things easier. So I'm just going to literally copy down B underneath. Okay, so next I'm going to remind myself that I'm working downwards now. So I just put little circles around these to remind me I'm going downwards. And I need to look at the sign before the letter that I've made the same coefficient. So I'm looking at the x's and I'm looking at the signs before them. If the signs are the same, we are going to subtract. If the signs are different, we're going to add. And it's that simple. Okay. Now the signs are the same because they're both positive, so we are going to be subtracting. So a minus there, a minus there, and a minus there. Okay, let's start. 4x take away 4x is nothing, which is good because it needs to be nothing. 10y minus 3y. Now 2 minuses make a plus, so that's 10y plus 3y, which would be 13y. And we've got 48 plus, because the 2 minuses make a plus 4, which is going to be 52. I'm going to put my lines in. Okay, next I need to do 52 divided by 13. And we're going to do both of these divided by 13. So we've got y equals, I think it's 4. So 4 times 13 is 52. So yeah, y equals 4. Then I'm going to pick one of the equations from the question and I'm going to substitute the 4 in. I'm just going to pick the top one. So 2x plus 5 times 4, because we know that y is 4, equals 24. And again, put my lines in. So it's 2x plus 20 equals 24. Take away 20 from both sides. 2x equals 4. Divide both sides by 2. Extend my lines a little bit. And x equals 2. Now if you've got time in the exam, you can check that that's right by using the second equation. So 4 times 2 is 8. 3 times 4 is 12, and 8 take away 12 is minus 4, so we know it's correct. So x is 2 and y is 4. So this question says there's two triangles that are congruent. Now congruent means exactly the same shape, exactly the same size, exactly the same angles, exactly the same length. Now the important thing to notice is this angle here and this angle here are not the same. However, if you work out what this angle is, well, this is going to be 105 plus 35 and then take that away from 180. So it'd be 180, take away 35 plus 105. Now 35 plus 105 is 140, and so that's going to equal 40. So this angle down here is 40 degrees, which is the same as this angle here, and similarly this angle here is 35 degrees. So these triangles are not the same way up, and that's going to be important, because if I redraw this left hand one, I'll just do it roughly. If I redraw it the same way as we're trying to find G, so I'm going to redraw this first one. So if I redraw this first one so it's the same way up, well, this is still going to be 105 degrees. This one here is going to be 40, so I'm going to switch that around. The long one is still going to be 11 meters, and this one down here is going to be the 35 degrees. Okay, the one between the 40 degrees and the 105 degrees is 2 meters. The one between the 35 degrees and the 105 degrees is 3 meters. So therefore G, which is this one here, is going to be 3 meters. Now a really common wrong answer to this is 2 meters, because it's the same as this one. However, you can see that the triangle's not the same way around, so we've flipped it. And be careful, this is exaggerated, because in the exam the triangle, the lengths will look similar, but these are not drawn to scale, so don't just rely on the fact that it looks the same to assume that it is the same. In this question we're asked to compare two banks, and normally when I'm asked to compare something I just put a line down the middle of the working out, and I put one of them on the left hand side and one of them on the right hand side, and as long as it's identifiable which one is on the left and which one's on the right, you don't need to necessarily put the whole name down, but you can do. So I'm going to start with a super bank. It says we have 2.3% for the first year and 1.8% for all other years, and we're doing this for 2 years at £300. So first of all I want to work out what the multiplier is. Since this is the calculator paper, we use the multiplier method. So we start off with 100% always, and compound interest means we're gaining money, so we're going to go up by 2.3%. So that means we'll have 102.3%. So as a multiplier, what we do is we just divide that percentage by 100 to get it as a decimal into what we call a multiplier, 1.023. So if I times 300 by that, that will tell me what we have after year 1. So let's do that on a calculator. 300 times 1.023. And you might need to press S to D. And that is £306.90. Okay, so that's year 1, and we might as well just write year 1 somewhere. Okay, so year 2, we've got that £306.90, and we need to work out the multiplier for 1.8. So I could go through the same method as before, but actually when you start using multipliers you realise how to just go straight there. So it's going to be 1.018, but you could do 100 plus 1.8 is 101.8 and then divide that by 100. And what's that going to be? So that equals came out a bit wrong. So what's that going to be? So 306 and times 1.018, and that says it's £312, and I'm going to round this 42. I'm going to round it to the nearest penny. Okay, so that is super bank. That's how much we'd get. Now the great bank's a bit easier because it's just going to stay at 2.2. So let's work out as a multiplier. 100% plus 2.2% equals 102.2%, and then as a multiplier that is 1.022 by dividing it by 100. So we're going to times that £300 by 1.022. So 300 times 1.022, and I get £306.60. Then I'm going to times that again by 1.022, so times 1.022, and this time I get 313.34. Ooh, actually, that would be 5 if I round it to the nearest penny. Okay, so it says, which account will give her the most money? Well, looking at that, it's going to be the Superbank. And when you're writing down an answer, make sure you write down the full name. Oh, it's not going to be Superbank, it's going to be the Great Bank. Look at that. So Great Bank Inc. And it says by how much. So I'm going to get that by how much. Let's show the examiner what I'm doing. So I'm going to do 313.35, take away 312.42. So 313.35, take away 312.42. And I get the answer of 93p. So £0.93. Now, if you hadn't have rounded both of those, you might get a slightly different answer. And actually, technically, you shouldn't have rounded them until you got the answer. But on a question like this, where you're rounding it to the actual money she would get, they wouldn't pay her half a penny, then either answer would be correct. And in this bit here, you could have done all of this just as one bit. You could just written 300 times 1.022 times 1.022 or times 1.022 squared. That would be absolutely fine because you'll get the same answer. Okay, with this question, the first thing to realise is that we have two similar triangles here. So we've got the smaller triangle here, and we've got the bigger triangle here. And they are mathematically similar because this angle is going to be the same as this angle because they're parallel lines, those are corresponding angles. This angle is going to be the same as this angle for the same reason, and this is a shared angle. So there are two triangles with exactly the same angles, therefore they have to be mathematically similar. And mathematically similar means all the angles are the same, but we've just multiplied all the lengths by something to get to the new triangle. So, important first step of this is to draw out the two triangles. Okay, and I'm just going to sketch them out roughly. So a small one, and we've got the big one. And then copy the length. So this is going to be 23, this is going to be 9, this is going to be 36 at the bottom here, and this one's going to be 60. Okay, now ask for the value of CE, which is this bottom length here. That's the bit we're trying to find. But I'm going to ignore that, and I'm going to work out what AC is. The reason for that is if I know AC, I can take away from 60 to work out CE, because I know the total distance is 60. Okay, to do that, I need to work out what the scale factor is. And the scale factor, all you need is a length on both of the triangles, which is corresponding, which means it's the same length, but on the two different triangles. And to do that, we do the big length. I say the same, it's not going to be the same length, but the same position on both triangles. So big length over small length. Okay, so the two I'm going to pick is obviously the bottom two. And we're going to find out what we times 9 by to get to 36. So 36 over 9. And that's obviously going to be 4. Okay, because 4 times 9 is 36. Okay, so we know we times that by 4, so the scale factor is 4. Now, if we go from big to small, we times it by 4. But here, we're going from, so if we go from small to big, we times it by 4. But here we're going from big to small. So instead of times by 4, we're going to divide it by 4, because it's going to get smaller, isn't it? So we're going to do 60 divided by 4, and I should really write down what I'm doing. I'm doing AC. and that's going to be 15. So we know that it's going to be 15 here for this bit, okay? But the total is 60, and we're looking for what's left over. So we're going to do CE equals the total 60, take away the bit we know that we don't want, and that's going to be 45. So the answer is 45. Okay, so we've got an athlete and 2 hurdles, and if he jumps the first one, the probability of him jumping the second one will change. So it's a conditional question, and we're asked what's the probability he will hit 1 hurdle. Now 1 hurdle does not mean 2 hurdles. 1 hurdle means exactly 1 hurdle, so you've got to be careful with the question. Okay, so we start here, and if he jumps the first one, then we're looking at him hitting the second one, because he has to hit a hurdle. So we're looking at him hitting the second one. If, however, he hits the first one, he can't hit the second one, otherwise we'll end up hitting 2 hurdles, and it says it will hit 1 hurdle. So he has to jump the second one. So he's either going to hit the first one or the second one. Okay, what we need to do next is work out the probabilities he will jump the first one, then hit the second one. So we just get the 2 fractions and times them together. So that would be 4 over 70. No need to cancel at this point. Okay, and let's work out the probability you hit the first one and then jump the second one. So that's 3 over 7 times 10 over 13. So that's going to be 30, and then I could do this on the calculator or just do it in my head, over 91. Okay, now we're either going to end up here where he's hit the second one, or here where he's hit the first one. The word or in probability means add. So he's either going to hit the second one, or, which in probability is add, hit the first one. So on the calculator, because this is a calculator question, so it'd be 4 over 70 plus 30 over 91. So that's going to be 176 over 455, and let the calculator do the hard work there. Now, if it's a non-calculator question, generally speaking, the denominators of the fraction are a little bit simpler, and they tend to do those on the independent ones because they can manipulate the denominators a little bit more. Okay, I'm just going to write this out to make it a bit bigger. Now we're asked to make A the subject, which means we want A equals. So I'm going to put my lines down. Now the first thing I need to do is get rid of that square root, because if you look, the right hand side is all trapped in that square root. So what I'm going to do is square both sides. So we've got t squared equals, and when I square the square root, it just gets rid of the square root. Okay, next I need to get rid of that 3, so I'm going to take away 3 from both sides. So we've got t squared minus 3 equals 10a. Then I'm going to get rid of that 10. Now that's a times 10 there, so I need to divide both sides by 10. Now I could divide the t squared by 10 and the 3 by 10, or I can just write it as a fraction, which is a lot easier. So just put the whole thing over 10. So therefore a equals t squared minus 3 over 10. Now it's really important that if the letters are capitals, we keep them as capitals. If they're lowercase, we keep them as lowercase. It does matter what case the letters are, so if it's uppercase or lowercase. Okay, so question A is about reverse percentages. So in 2014 and 2015, well, let's have a look. So the sales went down between the two. So if we start off with 100% and they went down 12%, what we're left with? Well, we're left with 88%. Now, as a multiplier, and this is the best way of doing this, 88% divided by 100, make it a decimal, is 0.88. Now that number, 0.88, is what we times the 2014 sales to get 2015. But in this question, we're given the 2015 sales, so we're given this one here. So we want to work backwards. So what we want to do is I'll get my calculator, 7,359 divided by 0.88, and that gives me £8,362.50. You've got to ask yourself, well, is that reasonable? Well, they went down by 12%, so it's natural that they would go from a number around just over 8,000 to a number that's just over 7,000. So I'm going to write the answer, £8,362.50. Okay, the next question says that the sales went up in 2016, or they have a target to get their sales up in 2016. What's the percentage increase? Now, percentage increase or percentage decrease, it's the same formula, is change over original times 100. So the change, well, that's going to be 12272, take away the 2015 sales, so that's that one there, 7359. So they're looking for it to change by 4,913. The original was at 7,359, and we need to times by 100. So I'm going to divide that by 7,359, times it by 100. And that gives me 66.7617, blah, blah, blah. So that's to the nearest percent, so that's going to be 67%. I hope you enjoyed that video. Don't forget you can go to our website onmaths.com, which the link will come up there now, and to do the paper online, or to check out our other stuff. We've got topic busters for all of the topics that can come up. Don't forget that this is only a practice paper. We call it a prediction because what we've done is we've cut out the stuff that we feel has come up in paper 1 and 2, and so leaving a few topics that we select which ones the exam board generally goes for in paper 3 on the calculator or paper. So it's only a bit of practice. Please don't rely fully on this paper at all, and just make sure you do normal revision as well as this video. If you've liked this video, please click like. If you really like it and want to see more from us, especially in the next few days, please click subscribe. Thank you very much.